the top of the hour at here in 2 o'clock here in South Africa. So we're going to start our session. So we have 5 papers that to present at this panel, and each paper presenter will get, as we indicated in advance, 12 minutes to present, and then we'll have 5 minutes approximately for questions and answers and comments. And then it'll be, a couple of minutes we've allotted for transition if, there is a little run over. So I'd like to introduce our first presenter, Malaz Ahmed, and her papers is Insights on Floating Agricultural Approach to Deal with the Spatial Implications of Political Economic Transition on the Agricultural Land, a case study of Al-Qalaka Al-Kwaba Khartoum. And I know I destroyed that, so you'll have to correct me, Malaz. So go right ahead. Thank you. Oh, you're on mute right now, Malaz.
I am I here? Okay.
Yes.
I'm muted by the host. Sorry. Hello? Can you hear me?
Yes, you're unmuted now.
Now I'm okay. Hello, everyone. I am Malaz Saif, and my presented studies assume the floating agriculture approach as an appropriate technology to cope with the impact of rapid urbanization on developing an efficient food production system. So first, the presentation clarified the linkages between urbanization and situation of food insecurity. Then it highlights the dynamic of urbanization in Khartoum. Thereafter, it highlights the situation of food insecurity. Finally, it illustrates the aspect of floating agriculture technology and some of the innovative floating farm projects from all over the world concerning achieving food security. Concerning the interrelation between urbanization and food insecurity, we find that the current Sustainable Development Goals, SDG, shed light on the direct linkages between urbanization and deterioration in natural resources, food insecurity, poverty, and sustainable development. Because of the interrelation between the process of urbanization and food security, food availability, food access, food utilization, and food stability. However, in developing countries, the dramatic demographic change has created an obstacle to developing the food production system to satisfy the demand and needs of people living in urban area. On the other hand, the dramatic changes that passed through Bilad al-Sudan recently since the beginning of the 19th century changed the characteristics of Khartoum from a hereditary religious system under the command of dependent on cultivating into gaining comparative importance as administrative and commercial heartline. On the other hand, after independence, from the Anglo-Egyptian condominium in the middle of the 1950s, the capital faced with considerable momentum of migration from rural Sudan because of the concentration of political power, administrative authority, and financial control in the city. By the 1980s, the large-scale exodus of rural population on account of the political and economic crisis that expand the gap between prosperous heartline and peripheral regions beside the catastrophic environmental and natural disasters shape the spatial fabric of the city with black belt of black settlements and continuous illegal subdivision in the agricultural land of the old villages alongside the blue and the white Nile banks. which expand the trend of spatial and demographic growth of Khartoum, as shown in the following figures and aerial images. Here, Khartoum in 1980s, and here in the 1990s, 2006, and 2016. Regarding the case study of this research, Al-Kalakla Al-Gubba, which is one of the old villages of Jabalawliya locality, which has supplied the center market of Khartoum by food supply since the time of Turkey during the 18th during the 19th century. Subsequently, it witnessed a remarkable increase in the area classified by urban by 400% between 1970s and 2018, and remarkable decrease in the agriculture area, as shown in the in these two images. Accordingly, it's unsurprisingly that 9.6 million people are experiencing high level of acute food insecurity and require urgent action. 2.2 million facing an emergency acute food insecurity situation, and around 7.4 million people are facing crisis acute food insecurity. And 15.9 million people are estimated to be in stress. Food security remains alarmingly high in Sudan, with increased and protected displacement, economic decline, inflation, and high food prices, price hikes, which exaggerated by the impact of COVID-19 pandemic. Back to our question, how to achieve urban food security, we have to understand the meaning of food security. Food security is defined as the situation that exists when all people at all time have physical, social, and economic access to sufficient, safe, and nutrition food that meet the dietary needs and food preferences for an active and healthy life. How to achieve food security? It's influenced by aggregation of food availability, food access, food utilization, and food stability. It's relied also on the efficiency of food supply system, which consists of large-scale food production and processed supermarket, urban agriculture, imports, beside potential of rural potential. When looking at the concept of urban sprawl situation, as happened in Khartoum, the study assumed the floating agriculture approach, which referred to the hydroponic technique, which cultivate plants, vegetables in nutrient-rich solution water, which has been used in developing countries like Bangladesh for more than 2 centuries ago to plant any vegetable and seedling. The traditional floating agriculture platform consists of decomposing heaps of water, hyacinths, and upper surface layer of ashes, coconut fiber, and sometimes soil to allow plants for spread. Eventually, the smart floating farms are designed as smart and fully automated system that combined of solar energy and hydroponic and aquaculture. The smart floating farms comprises of 3 main levels. The ground level for aquaculture, the first floor for hydroponic crop cultivation, and the rooftop level covered in solar panels, skylights, and rainwater collector. Each model is estimated to produce about 8,000 tons of vegetables and 1,000 tons of fish annually. Another example in Netherlands, Rotterdam, demonstrate a new sustainable way of producing food. Dairy farm, floating dairy farm. When it reaches its capacity of 40 cows, it will produce about 800 liters of milk daily. The farm also pasteurized the milk, turned some of it into yogurt on the middle floor of the banton, whereas the manure is proceeded for use as fertilizer. Finally, the floating farm poultry is designed in succession of the floating farm dairy, similar to the adjust cow farm. It's organized logically stacked and compact agriculture building, which contain about 7,000 hens, fresh egg, and crops, and so on. Thank you.
Thank you very much, Malaz. This was a very thoughtful presentation, and I'm excited about how this is being implemented, particularly in the Sudan. I noticed you gave examples, in terms of various versions of the floating farm. Could you say something about how it's being implemented or planned currently for the Sudan?
It's not. I suggest this model to be implemented in areas which affected by urban sprawl, but unfortunately, we don't have similar projects like this in the White or the Blue Nile.
Okay, because I've had the opportunity to visit Khartoum for a couple of times, and in that area just seems like quite an opportunity, right where the Nile splits to actually implement what you're talking about. So I wish you the best on pursuing this. Are there other questions from our panelists on this project? You can raise your hand, or you can put it into the Q&A or chat box. Do we have anything in the chat box? Pule?
No, we don't have anything in the chat box.
Okay.
Okay.
So if there are no questions, further questions for our panelists, I'm actually the second presenter. And one of the reasons I was excited about what you were saying is that I'm also very interested in how you deal with the city in terms of realizing this rapid growth, particularly in African cities. Pule, if you can hand me the presentation, all I can then move to share.
Thank you.
Thank you, Malaz, for that presentation.
Thank you. Thank you.
Pule, can you hear me? You need to move the presentation
Yes,
ball
Prof.
to like, okay. Okay, thank you.
Thank you.
Okay, can everyone see my screen now?
Yes, yes, Prof. We can see your screen.
Okay, thank you. As it indicates here, the title of my paper is Infusing Circular Economy in African Smart Cities. My co-author, Mr. Puluwa, is also at TUT, where I'm a professor and also director of INAT. I'm going to cover these 5 topics in my short talk, starting with discussion on Africa's urbanization challenges, which, as I indicated, really overlap with the previous paper. And then I'm going to talk about smart cities in general, and then focus on circular economy as an appropriate technology, since this is appropriate technology conference. I'm going to then look at supply chain management within the context of a circular economy, and then look at how we're using in our effort knowledge management to invoke and create this smart African cities. So first of all, in terms of just looking at the issue with regards to African urbanization, as Laz mentioned that this is and she gave it in some particular numbers with regards to and the Sudan, but urbanization is growing in Africa faster than any other area. Uh, while prior to colonial independence, the vast amount of Africa was rural, and cities were small compared to those in the Western countries or so-called developed countries, uh, and that the city structure was set really to facilitate the colonial administration. So what was inherited in terms of post-colonial was really a structure that did not address really the needs of Africans and particularly the Africans in these urban areas. So what we're seeing is this fast-paced urbanization, and unlike urbanization in many developed countries, which was driven by a increase in industry in cities that first grew fast, like London or New York or Chicago, um, and people came to the cities for jobs. In the case of most of African urbanization, people are going to the cities looking for a better life, but there is not the job situation based on urbanization. So it's not creating the urban jobs and the pace of the urban growth. And another thing, compared to many other large cities, there in Africa, we see this what's called the youth bulge, in that because of the population growth rate having been much higher in recent years, that and also because of the character of most people a lot of people who are moving from rural areas being within a certain age range, that there's a youth bulge in Africa, but it's even more pronounced with regards to the cities, as many youth leave rural areas for the cities, searching for a better life. So this is phenomena that has to be taken into account when we look at how to address any of the problems within the cities. So within the context of smart cities in general, we see that the smart cities are designed to connect the various resources, uh, the various government agencies, organizations, both corporate organizations, independent organizations. The idea is to have this connectivity within the smart cities, so to facilitate both citizens and also visitors. Uh, Smart cities have been even particularly addressed in terms of how to increase tourism in terms of making it more attractive to visit by visitors in terms of being able to implement certain types of smart environments and the use of what are called smart devices. So there are two things. There's a existing converting existing cities into smart cities, and then now what's arising is the notion of creating whole new cities as smart cities, in terms of sort of orchestrating the urban growth patterns by actually building in certain areas so to attract populations, but within those settings, actually taking into account that you're planning for urban growth and being able to build infrastructures from scratch. So this notion of being able to convert cities or versus being able to create smart cities from scratch. So sustainability is the key here in terms of what we want to deal with smart city, in terms of both being able to enhance the government and governance, and at the same time being able to improve service and service delivery. So I want to shift now in terms of the notion of how economies basically function, particularly within this manufacturing economies. This linear model is what is traditionally happened. You have raw materials and you go into production and there's some use and then there's waste that has to be dealt with. So we realize that the cities represent a kind of closed system in that you're dealing with many activities going on right there, and you have to deal with not only production but all the way to, like it indicates here, the waste issue. So it becomes a real issue, and many things have come up with regards to that. So there's this move in terms of looking at the feedback loops, and this is the second model that you see here, where there is some recycling that's going back into production with regards to this, but there's still some residual waste here. But the circular economy notion is that it's all, within a closed system, that everything is either sustainably used or it's recycled. And that key to that here is you see this new element here, what we're calling sustainable production. And that this is a key aspect, particularly looking at manufacturing. The focus on a lot of the circular economy is around manufacturing, uh, because that is one of the big waste producers globally. So looking at circular economy, it's about applying the circularity with material cycles that you see there, but it's also about reusable energy flows. So that one of the things that's more a focus with circular economy is more effective energy development and utilization. So there are various motivational drivers that are associated uh, with developing a circular economy, and they have been grouped in terms of these categories, looking at issues with regards to policy in the economy, health, environmental protection, and more broadly society, and then the whole issue of product development, which is more of the focus that we're doing at TUT because we're engaged in industrial engineering department. Oh, okay. Okay, there are five fundamental traits we associate with the circular economy. That's designing out the waste from the beginning. So this is where you saw the earlier model, this sustainable design production, rather, because you want to actually, from the design perspective, figure out how to eliminate waste. And that actually this resilience coming through diversity within the processes you're dealing with. And then thirdly, working toward energy from renewable sources. And I mentioned that in the previous slide. But the thing that I'm big on, because I'm trained as a systems engineer, is thinking in systems. And this is where I started out saying that viewing cities as a closed system is important, but also thinking in these cascades that you see in terms of how you're going through different stages and where you are with regards to the stages in terms of viewing your system even as a cascade of processes. So what we're looking at in our research is how to infuse this our concepts of supply chain with the circular economy, because then we can more broadly look at the overall processes of production. So with regards to the supply chain, we realize that we have these supply chain drivers that we have to investigate in this process. And then this is divided into logical drivers, such as of looking at the facilities that you actually have in terms of your processes of production and distribution, the inventories that you have to maintain, and then the transportation that goes along with the whole supply chain. So looking at these with regards to the circular economy and in terms of how we approach this as a smart city is all part of what we're addressing. And then we have the cross functional drivers that are associated with that. And most importantly, what we're looking at is information and information systems, but also with that, the issue of sourcing and pricing have to be considered in any supply chain management system. And certainly when we're now trying to deal with the issue of circular economy and develop this as a smart city, we have to take this into consideration. So what we did was we took a knowledge management approach to examining these different cross-cutting issues of the circular economy and supply chain, and in terms of envisioning how we would approach the development of smart city. And this is about categorizing our practices and identifying best practices. This is a sort of a cornerstone in knowledge management. And the key research themes that we looked at was the socio-technical approaches to smart cities in terms of previous studies, integrating knowledge sharing perspectives, and developing organizational learning capabilities in this whole process of employing knowledge management in terms of how we go about smart city development. Other literature that we looked at was around developing a taxonomy of these various smart city initiatives to give us some background in terms of how we would approach it with regards to Smart Cities Africa. So this is what we then came up with in terms of how we wanted to infuse supply chain notions in terms of the circular economy in terms of working, so that we started out with initial stakeholder engagement, and this is where we looked at the primary stakeholders, which were the communities, workers, citizens, and even visitors. And with that, then moving to looking at data collection, and this is where really the knowledge management system is key, because information and knowledge acquisition and structuring into databases became a key thing in terms of how we were advocating you would need to do this in terms of how you would approach invoking circular economy and smart cities. But then this data collection has to lead to the manipulation of information systems around the databases and the knowledge management systems being used to generate new knowledge. And this is in the form of possible scenarios and project alternatives. So this is where you're really key in terms of how what you're doing with this investigation with stakeholders and data collection and coming up with various scenarios for how you would approach development within the context of the smart cities. And that's where you then leads to project selection and the scheduling. And this is where all the portfolios will address basic needs. In this case, you're looking at water and sanitation, energy, health, housing, communications, education, and security projects that would make up these portfolios that you would examine. And the e-government systems would then have to be invoked in terms of providing the monitor the implementation of the selected projects portfolio that would maximize citizen and community engagement. So e-governance is different from e-government in that the e-governance is more centered around citizens in terms of enhancing their involvement in the process. Then addressing the circular economy drivers across its life cycle and the supply chain for the different portfolios. And this is where the endogenous within projects and the impact of delay must be captured in terms of that. So next, the stage is this linkage among the projects. And this is where attention must be paid to the impact of delay and risk and maximum control over decisions because the endogenous relationships really dominate the processes that we're engaged in. And this ends us with the actual development of the smart cities to be viewed. And this is a continuous process requiring periodic assessment and adjustments that feed back into the e-governance system and also provisions for the extension of the smart city portfolio. So this is where we are in terms of just expanding this whole concept. So the African city smart city development must reduce inequality while improving the quality of life in the city. So this is key and is in line with what we're about with regards to appropriate technology in terms of empowering communities. And this also is about strengthening democracy in the city while empowering these local communities. So effective use of this technology, various technologies of associated with smart cities, particularly in regards to ICT and the knowledge management system associated with it, are key to the sustainable smart city. The next thing in my final slide is we're looking at extending this work in terms of coming up with a more robust knowledge management system that sort of fleshes out what we talked about in that flow chart with regards to knowledge management and also focusing in on the e-governance component within regards to that. The other thing that we're looking at is to actually look at the construction of mixed mode simulation models to study the potential benefits of the different smart city projects and portfolios. I'd like to end that and thank you at that point. Okay. Okay, are there any questions or comments on? You can either write in your comments in the chat or actually you can raise your hand also if you have any comments. Okay, I don't see any comments at this point. We can, I see that our next presenter is Renee, and she is putting up her slides now. So
Good afternoon. My apologies. I just was trying to switch on my mic, unmute myself first. I will. Thank you. Can you hear me?
Yes, Renee, you're audible.
Thank you so much. Maybe I should start, before I start my presentation, thank you for the two presenters that preceded me. I was wondering how my topic would fit into the session because it's about sanitation. And the first presenter
okay,
talked about...
you're breaking up, but While you sort that, let me just introduce your
Yes.
project, and maybe you can sort out the network connection you're having. Uh, the paper is titled Sanitation, Demand, Condition, and Coverage, Ziptopini Extension A, Informal Settlement.
Why is it happening now?
Yes, that's a little better.
Yep.
Why don't you go ahead now?
Yep.
You
Thank
can
you.
put the slides on full screen.
It's on full screen. I've put my slides on full screen already. Okay, can you hear me?
Yes, we can hear you.
Thank you.
Yes.
As I was saying earlier, I was wondering where my talk would fit in, but I'm very happy that the two presenters that preceded me talked about two things that that obviously food security is one issue. And sorry, for food, when we as humans consume food, we need toilets, on a lighter note. Secondly, I think there's something that Prof said as he was concluding his presentation. He indicated that in African smart cities, we need to development must reduce inequality while improving the quality of life for the city's population. Now, my presentation will highlight a few things around quality of life, as well as it will, I'm sure it will actually highlight inequality. So this topic, this research emanated from a full research master's project, and I will be presenting some of its results that relates to the sanitation, that highlights the sanitation demand in informal settlements specifically, and it will highlight condition of the sanitation, and I will raise a question at the end in terms of coverage versus condition. I want to acknowledge now the student whose master's project it was, Crescentia Decini Ulu. She's a practicing environmental practitioner for the city of Tshwane Environmental Health, based in Bronkhorstspruit. And my co-supervisor for the project was Professor T.G. Barnard, with the Water and Health Research Unit at the University of Johannesburg. So I want us to briefly just have a look at the importance of safe, acceptable sanitation, safe water, and hygiene for health. And what I'm showing you here is basically what we call the F diagram, which indicates fecal matter. And obviously we need the toilet as a barrier there. Fluids, flies, fields, spores, fingers, which is basically referring to the personal and environmental hygiene. And then we need safe water for to fight that fight. And then foods, and then the host, who is obviously us. I also want to briefly refer to SDG, Sustainable Development Goal 6, which focuses on clean water and sanitation. And it has 4 targets, and I want to highlight the first 3, which indicates that no one should practice open defecation by 2025. Note, we are in 2020 at the moment, almost in 2021. The second one I want to raise is everybody uses basic drinking water supply, and it should be available at home. And the target 3 is by 2040, everyone using adequate sanitation at home. The emphasis is again at home, and that excreta from at least 50% of the household, schools, and health centers are safely managed. And then lastly, target 4 indicates all drinking water supply, sanitation, and hygiene services are delivered in a progressively affordable, accountable, and financially and environmentally sustainable manner. So I'm now going to quickly just review what is the joint monitoring program of the WHO and the UNICEF has said about improved drinking water sources. And in there, I've inserted a picture of the drinking water source for Zitubeni informal settlement. And from this table, we can basically see the differences between improved and unimproved drinking water sources. And I can safely say that this particular local authority or municipality has done their part in terms of delivering improved drinking water sources to that community. As we move forward in terms of improved sanitation technology, we can see here the differences or the requirements for improved versus unimproved sanitation facilities, where the improved sanitation facilities is clearly defined as flush toilet, where that's what we as humans expect. Flush or poor flush, the various types up to pit latrine, a ventilated improved pit latrine, composting toilet, etc. And I think the appropriate technology for sanitation is evolving all the time. But now let's look at the unimproved sanitation facilities. And I want to highlight specifically the bucket, pit latrine without a slab or open pit, hanging toilet or hanging latrine, shared or public facilities, and no facilities at all, or bush or field or open defecation. So this toilet, the insert here, is specifically referring to the chemical toilet, as it is the service that is available to Zitubeni informal settlement in city of Tshwane, Bronkhorstspruit. And then I quickly want to just jump back and see, before we head into the results of our study, I want to just reflect on the access to improved sanitation facilities according to, in South Africa, according to Stats SA in 2016, their report across the different provinces. And although in 2015, the Western Cape and Gauteng province led in terms of improved sanitation facilities by province, they really led in terms 90+%. However, what was the condition of the sanitation is the question. Maybe we are meeting the requirements for coverage, but are we doing it at the expense of conditions? And are we doing it at the expense of infrastructure and the health of the people? So the next slide, I just want to illustrate quickly the sharing of facilities, also from Stats SA 2016. The percentage of households who shared a toilet facility in a dwelling, yard, or outside yard was 87%. 87, yeah, let's say rounded off, 87%. Outside yard, which means this is not at their home. Toilet facilities in their yard was about 34%, and a toilet facility in the dwelling. These are for specifically statistics for shared toilet facilities. So in terms of shared facilities, we still have quite a high percentage, 87%, which is outside of the yard, which means there's a lot of other factors that contribute to either the demolition of the sanitation facilities. It has an impact on privacy. It has an issue. It has an effect on safety and security as well. So to briefly bring you back to our study that we've done in Zitubeni, in Extension 8 informal settlement in Bronkhorstspruit. The settlement is about 12,000 people, and that is about 3,000 households. And in total, we counted 129 chemical toilets. We basically sampled all those toilets, and we then interviewed about a certain number of households, which I will show you on the next slide. However, we did observation checklists for the evaluation of the sanitation condition We also took a number of swabs to see on the door handle, on the toilet seat, and to see what we find. We also even, as we interviewed the households, took some hand swabs and hand washing samples as well. But that is just a little bit out of the today's talk scope. But basically, we piloted the research tools in Pumzile informal settlement, which is a smaller settlement quite close to Zitubini, but still in the same area. So first and foremost, we want to look at the maintenance, hygiene, and cleanliness results. So from the main study, we did 140 households, and in the pilot study, 31 households. So we had about 171 households. So it was clear from that the community relies on the contractor to clean the toilet. We could see that it was done weekly, and also the supply of toilet paper obviously relies on the household mainly, but in the pilot city that was a bit different for in that case. Then we have the results of the chemical toilet use, and we basically noticed that 95% of the people said yes, they used the chemical toilets, and also about 80% in the pilot study site. We then looked at if people had to wait for the toilet. We looked at bad odor, flies present, whether there was flies, whether they could wash their hands, and whether there was water close to the toilet for hand washing purposes. And there was a clear indication that there was no water for hand washing purposes. However, 93% said they often do wash their hands after toilet use. And that was quite interesting to see. And the results of the laboratory test also kind of showed that there was a discrepancy there. We also managed to catch some flies, but that was done. Further research will be done on that. The next slide is really the crux of the presentation. Yet, although we interviewed those households, 170 households, we also did a walk about the entire settlement, and they are busy formalizing some parts of the settlement. However, what was clear was there is a demand for sanitation, that people do not feel safe to walk to the toilets at night, although the distance is not as far anymore, which I will report on just in a few minutes, in a minute or so. Mainly, the pilot study reported that using the chemical toilets was around, the pilot study about 80%, 95% of the main study, they're using the toilets, but there is still 7.6%, almost 10% of the households that did not use the chemical toilet all the time. And that means that they either used alternatives for toilet activities, private pit latrines in their yards, which is not necessarily built according to specifications, bucket systems, which they would then dump or dig a hole and put it in there, but it's not really managed, it's not formalized, open defecation in a nearby field. And those practicing open defecation exhibited poor hygiene of the chemical toilets as the main reason. So the chemical toilets which is provided are dirty, it's not clean, and the reason for that is households don't take responsibility for shared facilities. So I briefly want to refer to the condition of sanitation facilities according to Stats SA. It highlights a number of things like poor lighting of the area, especially at night, poor hygiene, physical safety, especially for women, and then the chamber will be full, no hand washing facilities, long waiting times often, and poor maintenance was some of the most reported issues in terms of Stats SA's survey. Now, when we did our survey in 2018, the findings indicated 77% of the chemical toilets had cracks or were damaged, and that can be ascribed to either the heat and or vandalization. 66% of the doors were not in good condition, working condition, and then 74% of the door levers were not working, meaning that the toilet door can't close, and that also creates a safety issue. 66% had no ventilation pipes, and that contributes to the whole the management of flies, etc. So availability of hand hygiene facilities, hand washing facilities was an issue. So there's our statistics: 83% of the chemical toilets, and 90% had no toilet paper. So the majority of the chemical toilets had no access to hand washing facilities, and only a few of the toilets were located close to the communal taps. And then unsatisfactory environmental hygiene due to the presence of flies, and about 79% of the people reported that. Also bad odor, open defecation, and then these conditions may be associated with the location of the toilets on the street boundaries, resulting in the lack of ownership and accountability by households. And it obviously also it's open to anybody. It can be vandalized. Nobody takes ownership for it. The distance, however, to sanitation facilities has decreased because according to Stats SA 2016, they indicated that households who lived more than 200 meters away from the outside yard toilet facility in rural or urban, and there was no really there was not such a big distinction between the two. So at that time, it was about 200 meters away. They were about 200 meters away and had to walk quite a distance. However, according to our findings, in 2018, the furthest distance from the household to the chemical toilet was less than 140 meters, and which I commend the municipality for. However, it's still not enough. So I'm going to start concluding now. The study then revealed a decrease in the walking distance from the households. The improvement in the walking distance attests to the efforts of government to provide better sanitation services to informal settlements in their commitment to realize the SDG sanitation goal by 2030. And according to Gonzalez, 2015, the average walking time to and from a toilet was estimated to be about 2.5 minutes. However, some more research needs to be done to assess the average acceptable travel time per trip to the toilet. Besides spending time walking to the facilities, households also indicated they had to wait once they reached the sanitation facility. Our research therefore finds current practice of providing temporary sanitation facilities unsustainable, and sanitation facilities were generally available, but the conditions were unhygienic, with some technical aspects that needed attention. Households expect local authorities to keep the facilities clean and are not actively engaged in its maintenance. However, houses do not take ownership of the facilities since they offer a shared service, and that creates an opportunity for poor maintenance and misuse or vandalization. Therefore, the findings of the study confirm that behavioral and environmental factors interact with the determination of the hygiene status in communities. Therefore, I think this is my concluding slide. Providing sustainable and improved toilet facilities would increase human health in informal settlements and contribute to reaching the SDGs. Most of these facilities do not count as basic sanitation based on the indicators such as the compromised safety, privacy, dignity, and cleanliness. And there is a high demand for sanitation in informal settlements, and effort by the government to address sanitation needs. The households often reject the facilities that's provided, especially when it's done without them being part of the decision-making process. Increased demand for sanitation facilities does not always translate into increased use of sanitation facilities. And my concluding statement today is sanitation coverage in response to sanitation demand cannot supersede safe and clean conditions of improved sanitation. I've come to the end of my presentation, and that is Crescentia, our master student from Ghana, while we were doing our field visit. And this candidate basically, she graduated earlier this year with a master's degree. And this work that I presented today was just probably 25% of her full research project. And we want to just acknowledge the University of Johannesburg for the funding, and then the Water and Health Research Unit that dealt with all our sampling, doing all the lab work for us. Yeah, so I've come to the end of my presentation. Thank you very much.
Thank you very much, Renee. Any questions from the audience? I have one quick question. This is all chemical. While you're unsharing, so that we can bring the next speaker up. While these are all chemical toilets that are shared, my question is how the chemical process involved. How toxic is it? And then what happens? I mean, in terms of the waste, are these toilets periodically emptied by some company who does this?
Yes, that's correct, Prof. These toilets, it's chemical toilets, so there's a chemical agent that's being added to the waste to kind of, manage it, and then it's emptied on a weekly basis. And often this service is outsourced to contractors who are then also responsible to clean the chambers. And then maintain it, the superstructure, and often that doesn't happen. So
okay.
Yes, so there's a break in the chain.
Yes.
Yes.
Okay. Our next presenter has the presentation option. She can now show the slides. If you have slides, I assume. Okay, yes. So this paper is titled "The Use of Open Source Platforms in the Development of an Appropriate Irrigation System for Small-Scale Farmers in Johannesburg." So McKinney Paxton and Martin Bolton. The floor is yours.
Afternoon, everybody. My name is Oratile Mokatla, and I'll be presenting a paper to you, as Professor Trimble said, on the use of open source platforms in the development of an appropriate irrigation system for small-scale farmers in Johannesburg. This paper is co-authored by myself, an assistant lecturer in the Department of Industrial Design at the University of Johannesburg, and senior lecturer Martin Bolton, who is within the same department and institution as I am. Can everybody see my screen?
Yes, Oratile, we can see your screen. Okay,
good, thanks. I'll start off with a short introduction into the study. In South Africa, there's an ever-growing need to curb hunger, and this has given a great emphasis on agriculture as one of the avenues in which this can be mitigated. In South Africa, the agricultural sector is unfortunately one of the most water-intensive industries, consuming about between 51 and 62% of all freshwater sources. Water, because of its direct correlation with food production and agriculture, is the greatest limiting factor, especially in the current climate issues that we have. So they points to a need for more rigorous resource management, and in this case, water resource management, to meet these growing food demands for both higher food production in urban and rural areas. However, to meet these water demands, there need to be an improvement or development of existing systems and infrastructure that would increase efficiency of water use without causing too much more burden on the already dwindling water supplies. New technological advances enable for the management of such resources and the development of appropriate technology that meets these requirements. And there's a need to develop appropriate technology that meets these requirements. And in this case of the study itself, this relates to water use in agriculture, and therefore these intended users are the farmers. Benefits for users of appropriate technology come forth by tailoring solutions or equipment to their needs and wants. And technology that is appropriate in this sense can make farming a viable activity for these small-scale entrepreneurs. In the developing world, unfortunately, most of our infrastructure and technology is imported from developed countries, and therefore it is not always the most contextually appropriate technology, and therefore there is quite a severe need for us in Africa and in other developing nations to be developing technologies and infrastructures for ourselves that are tailored to not only our needs but our capabilities as well. So I'll take you through a short methodology of how this study was carried out. Because the farmers were at the center of the design insights that drove the development of this appropriate tech, and in this case, irrigation, it was qualified to be a human-centered design, meaning that the farmers themselves are the humans in this case and are at the forefront of the informative process of data gathering for the study. Through putting needs of the farmers at the forefront, human-centered design ensures that technology that is developed for the intended users themselves within their needs, wants, and capacity. And therefore, appropriate tech is then that which encompasses all of this. In this case, human-centered design and appropriate technology are seen as sister ideologies that cannot be separated. The human-centered design here was cut into 3 different categories or stages, starting off with the here, which was interviewing farmers and data analysis from those insights. Moving on to the create stage, which was expert consultations and the creation of a working prototype that could then be presented back to the farmers. In the 3rd stage, which is the deliver stage. In this deliver stage, there would then be testing of the prototype by the farmers themselves, and insights that were gained from this testing would then be put back into an iterative loop to create a final prototype that would meet all of the requirements and the second iterative process of data gathering. Also finishing off in a conclusion of future design improvements that would be done for a market-ready prototype. We will start off with the here stage of the data gathering. So 7 farmers were identified through ties to the university, and these 7 farmers were chosen based off of their proximity to the university for ease of access, and also the different categories that were identified that were important. So farmers that already had experience in farming, farmers that had identifiable irrigation problems, and farmers that were willing, obviously, to take part in the study itself. So as you can see the map there on the right, these 7 farmers were located within Johannesburg City and also in nearby suburbs. Most of them were located with close proximity to the university, but there were a couple of farmers that were on the outskirts of the city, that is in Johannesburg North and in near Orange Farm, and obviously those in and around Soweto. So from the initial interviews that were carried on, it was an extensive qualitative process where it was intensive interviews. After those intensive interviews, obviously transcriptions. And from these insights from the farmers and the literature that was collected through secondary data gathering, a table or a synthesis of the farmers' insights and problems were noted down. As you can see here, these were pictures from the data gathering stages. So going out and taking photographic evidence of all of the irrigation problems that the farmers faced, from clogged irrigation pipes to irrigation that couldn't function because of low pressure, to inability to have permanent infrastructure on a farm because of tenure issues. So all of these were noted down, and the next table shows a synthesis of all of the insights that were gained from it, and shows a preliminary design specification based off of the specific needs that the farmers had. One of the most important things that the farmers noted was that they wanted a system that would be able to identify and alert them of their constant water use, logging all of that data. They wanted it to be as affordable as possible, and that if it were to be a full irrigation system that they could have, it would be something that they would want to have the ability to install and maintain on their own, in a way to keep costs down for them. So as you can see there, there is main considerations. So those themes are under cost and affordability, function of the actual irrigation system, how the farmers interact with the irrigation system through usability of it, and the sustainability of it in whole. So after this process, then obviously from the insights gained from the first stage of the data gathering, we move on now to the create stage of it. And this, as it denotes, was me sitting down as the designer and coming up with a design intervention that could be implemented for the farmers or tested by the farmers. So the first step for me was to sit down and critically assess what each of the different characteristics of the farmers and the farms themselves were. So as you can see there, there's characterization through farm size, current implemented irrigation system, the source of water, and whether the farmers would be a good fit for continuation with the study as a whole. So through initial desk research that I carried out, it was quite obvious that I would need to have an electronical system that would be able to monitor the water use of the farmers. And through all avenues that I pursued, it was quite evident that Arduino would be the best prototyping platform that could be used. Arduino is an open source hardware and software platform that allows users to build interactive products. And unfortunately, Arduino requires for somebody to have some basic or extensive knowledge of programming, and unfortunately, I didn't have that. So I turned to online platforms or online forums that were open source that could have information for me or insights as to how I would be able to tackle this problem. So GitHub was one of those platforms that I really heavily relied on to sort of give me an introduction to coding and looking at other people that had come before me, whether as programmers, makers, or designers, that had similar solutions and similar problems that they were trying to tackle. So I also looked to YouTube, which had tutorials on not only coding and programming, but also had insights as to how to prototype and manufacture the actual testing prototypes that I would have. On the bottom there, as you can see, is just an example of a code that I got online from a combination of these platforms. And this was my starting point for actually creating the water meter for the farmers. So after the initial research and getting the initial coding, a lot of these platforms also have a list of components that you would need to build the certain uploaded or available prototype that they had on there. So with that, I embarked on starting the testing phase of my design process. And as you can see there, these are just different screens of me trying different orientations, different codes that were available on the different websites, seeing how to properly calibrate the water meter for use in South African homes and South African farms. And this was just a iterative process of me going back and forth between different forums and different websites, seeing what works and what doesn't. And in the end, I came up with a basic water meter that could be able to measure the water flow for the farmers, to measure the water use for the farmers, logging weekly, monthly, and daily totals. And these were all of the components that were sourced for creating what we have now in the next slide, which is the final prototype enclosed there, as you can see, in a waterproof case. So after creating the water meter, I went back to look at the design specifications and looked at the fact that I would need to include other components and provide it in a kit system to the farmers. So in creation of the kit, I sat down and looked at all of the needs that needed to be fulfilled. And this is how the kit was created. So the final kit that was presented in the delivery stage to the farmers comprised of both the water meter and the drip irrigation kit. Although some of the components, including the water meter itself, had been extensively tested separately, only one farm was chosen to be able to test the kit in its entirety. So the contents of the kit were, as you can see, the drippers, connectors, drip line extensions, misters, and the water meter itself. And this was also provided together with a manual to the farmers. Because in the first stages of our data gathering with the first initial farmers, first 7 initial farmers, it was quite evident that the farmers already knew where to get irrigation systems, what kind of irrigation systems were appropriate for their farms, but there was a lack of information on how they could actually install that for themselves. So a lot of them ended up outsourcing the installation part of the process, and some, as you saw in the previous slides, ended up uninstalling the irrigation systems because they were either clogged as a consequence of not being able to be maintained properly. So this was also an intervention point that I felt was important to also give capacity to the farmers themselves to be able to maintain and install the irrigation system themselves. As you can see here, this is just an example of what the manual looks like. I'm sorry for that pixelated picture there. So the manual was the icons and the graphics for the manual. Open source platforms were also used in the creation of this manual. Looking back at the platforms that I mentioned before, that had 3D CAD models that were available that could then be exported to vector line work for the manual production. So after the manual was created, we then moved on to the actual delivery process of the kit to the farmers. So the kit was well appreciated by the farmers. And as you can see there, this is one of the installation processes at one of the farms that were chosen for the testing of it. So after installation of the drip kit, the irrigation system was left on for an extended growing cycle so that farmers could have a more interactive process of testing it, and given that insights back, as this is an iterative process, there needed to be another cycle of me sitting down with the farmers and getting that insights back as to what worked, what didn't, and what they would propose would be other points of intervention. And after the extensive testing with the farmers, there were a couple of insights that were explored based on their feedback. So one of the comments made by the farmers was that English was not everybody's first language, so there needed to be some sort of translation of the manual to other vernacular languages. So here on the left, you will see is an example of one of the pages of the manual that was translated to Sesotho. Obviously, this is just a sample, and there would need to be more consultations with the farmers as to what languages would be preferred. Sesotho here was chosen because it's quite close to my mother tongue, which is Setswana, and I could properly edit the manual as well. So you'll see on the right there, after testing as well with the farmers, there needed to be some small design changes that were made, and we moved on from the store-bought waterproofed enclosure to the 3D printed enclosure that you can see there that was used. So that was the final prototype that was done, and that was the end of the master's study at that point, but it wasn't the end of the research process. So I'll move on then to now the final outcome and further research points of intervention that were identified in the conclusion of the study. So the way forward from this would be to fabricate a batch of test prototypes that would be implemented with all of the participating farmers instead of one for an entire growing season. That would allow for also prolonged product use and deeper feedback from the farmers. Design refinements need to be done in order to make way for expansion of manufacturing suitable for batch production. When the final prototype was being done that was presented to the farmers, obviously this was done through rapid prototyping, and therefore manufacturing on that end was not considered as one of the main points. But if it were to be expanded, this would be necessary to explore. Before full product rollout can be done, there are plans to further research on the long-term benefits of the kit. Integration of Bluetooth and Wi-Fi modules within the water meter would make it able for me to expand out my farmers that I can test with. It wouldn't need for me to do trips to the farms themselves. All of the data could be accessed remotely. Farmers are more receptive of using visual aids than reading through the text. So further refinement of the manual needs to be done to include more pictures. More graphic aids and pictures and illustrations that would replace some of this text. In conclusion, the design of appropriate technology is not only one-dimensional, and the availabilities of these technologies also depends on education, support infrastructure, and thorough design intervention for successful adoption. As you can see with this kit, it was not only the water meter that the farmers required, it was necessary for me to sit down and look at other intervention points that may not have been identified by the farmers. So in this case, I was also serving as an expert in this study from my design background, looking at other intervention points that could not have been identified by the farmers, but were necessary for the success of the study. Throughout this whole design process, the appropriateness of the design was judged by its ability to solve the problems that had been raised by the farmers themselves. And the iterative process of the design process allowed for numerous consultations between the farmers and myself, whilst making all necessary changes from my side and from the farmer's point of view. The availability of many open source platforms allowed for the effective development of the system. And it's through this availability of accessible knowledge that allowed for immense number of technologies to be applied in almost any field. As I mentioned earlier, I do not have a background in coding, but open source platforms such as Arduino and GitHub allowed for me to carry out this project, even though I was not an expert in that field. And it's quite important to note also that for projects that have low budget availability, that this is an avenue or source that can be explored as well. Further research needs to be done to improve the market readiness of Toti. And this paper and study was just a proof in the fact that it can be done. And obviously there needs to be more work that needs to be put in for it to be ready for market.
Thank you. Thank you very much. We are going to have to ask the audience to submit questions to you because we're out of time for this section for your paper. And so anybody that has questions, please direct them to her. And we need to move to Martin, who he is here for the final paper. Martin, yes. You should have the screen share now and you can put it up. Martin's paper is titled The Development of Home Farm a Hydroponic Cultivation System Suited to Local Manufacture, and the authors are Martin Bolton and Michael Curran. Martin, the floor is yours.
Thank you very much. My name is Martin Bolton, a senior lecturer at the University of Johannesburg, Department of Industrial Design, and I'm sitting here with Michael Curran. He's CEO of Home Farm and Picture, and we are co-founders of Home Farm, and what we're going to present is the development of Home Farm and how it originated into this tech, agri-tech startup company. And yeah, so Michael's going to start off and then I'll take over in the design process.
Hi. Right, so looking at the problem of urbanization and rapidly rising global population, we were looking at food security and supply chains within cities and what role the consumer can play or the urban dweller citizen in addressing the challenges that are associated with food security and rising urban populations and how they can be empowered to grow their own food. So you can see by this chart the trend of urban population since the 1960s. And you can see by this diagram here how the food supply chain has become very convoluted based on the fact that food is now grown quite far away from where the majority of people consume their food. And so we thought this was quite an interesting problem, just looking at the particular contrast between the two modes of living, whereby you have your own food garden where you live and where you consume, versus the convoluted supply chain of farm, transportation, distribution, packaging, delivering, and then essentially consuming. So we looked at what role technology could play in addressing this particular problem. And as you can see, there are a number of appropriate technologies that are utilized within the agricultural sector. Hydroponics is the process of growing plants in soil-less grow mediums, whereby the water and nutrients are delivered directly to the roots of the plant. It's a very water efficient method of farming, and so it is gaining traction and popularity globally because of its water saving characteristics. Vertical urban farming enables you to grow food where traditionally you would not have been able to grow food. So in urban centers, and vertically implies the fact that you are basically taking what would be a floor space and replicating it one above the other in a modular fashion. Then you've got 3D printing, which we won't go into, but essentially the 3D printing, Martin will refer to in his section of the presentation, how we used 3D printing in the prototyping, fabrication, and ultimately the manufacturing of our solution. And then the Internet of Things also bringing farmers together, creating communities, networks, nodes, understanding needs and behaviors by virtue of the fact that you are able to connect with your farmers, your customers, and supply chains, etc. And then precision agriculture speaks to control systems, watering, lighting, fertigation that increase efficiencies and yields. So in developing our solution, this team from various backgrounds, including engineering, industrial design, finance, engineering, and design. And this is the product that we ultimately developed. It's called Home Farm. It's a home appliance that enables a city dweller to grow a variety of edible crops from the comfort of their home. And it is particularly targeted at those who do not necessarily have access to a garden by virtue of the fact that they're living in flats or apartments. And so they are constrained by that factor. The benefits include the fact that the crops are organic, pesticide free. You harvest as you need, so there's unrivaled freshness, high yields, limited waste, because you harvest as you go, so there's no chance of the crops sort of wilting in your fridge after a few days, for example. It's climate agnostic, so you can produce all year round. The technology that we've used and the design process that we followed means that the product is very easy to use, and by virtue of its high efficiencies, it is also eco-friendly. The technologies, again, quickly, that were utilized, we've got IoT capabilities, the benefits of which I mentioned before. We've got potential use of a smart camera, which is sold separately from the product as an aftermarket part that has an artificial intelligence component to it that can monitor the health of the crops that you're growing. It enables the user to run diagnostics on the crops by sending pictures and videos to the back-end system and to members of the team who can then diagnose issues or give advice to the user. We use full spectrum LED grow lights. We've got temperature and humidity control, auto watering, and a modular grow chamber, which is quite important when it comes to the modularity of the product, which you can see in this slide. So previously I spoke about the benefits of vertical farming, the fact that you can now use a limited floor space and you can now expand your farm vertically upwards. Modularity of the home farm enables you to achieve this result. Its modularity also enables multiple configurations within the home of the user, as can be seen by this below counter double stack. The technology that we adopted, we used to ensure an easy and seamless user experience. We wanted the product to be accessible to people who have not gardened before, so it had to be easy to use. It had to guide the user through the whole process from planting to harvesting. And in this, we utilized an app which the user can download from an app store, and it sort of takes the user through different growth cycles. It provides inspiration to the user of recipes that they can cook using the crops that they grow. And so ultimately that's the product we developed. That's the rationale behind the product. And we followed a highly sort of iterative and agile design process, which Martin will now take you through.
In order to allow us to get the solution to that final outcome, it had to allow a lot of flexibility and ability, sort of the opportunities to adapt and be forgiving through the process. This is the ideal scenario for where we are sort of currently wanting to be able to manufacture, which would be the home farm team being able to design, develop, manufacture, and assemble all under one roof. But this is not where we started. So the interesting part of how the journey began was that we started off working in our garages, trying to develop this concept and this idea to a level that is able to be believed and understood and to be sold to possible investors and possible users. And this, obviously integrating this, the physical part of the product, but also the tech side of the product, which is the brain and the operation and all the sort of integrated circuitry. And this was a very sort of strenuous and exciting process of development, where the initial platform that we used was using sort of Arduino and Arduino Mega platforms with all of the sort of available robotics components, and using standard sort of hobby breadboards and whatnot, just to try and get a proof of concept operational prototype. And the amount of investment that we were trying to sort of channel into this prototyping process was not a sort of unlimited collection. We were trying to use low-cost brandering, wood, standard hardware components. You can see the standard plastic trays in there, growing trays. There was some hydroponic nutrient testing there, standard fluorescent tubes, and trying to develop our idea, but using minimal resource inputs. This is the point where we had a working proof of concept prototype that we were able to present to possible investors and start the process of actually selling our idea to others. And this allowed for that iterative process of being able to deliver it to the audience or the people that can provide input, and then guiding that back into the design process. So you can see this is how the back end of the product was looking, where it was very starting to, you can see the design aesthetic coming through there, but you can see a lot of the componentry is still sort of, it's like on a lifeline at the back. Yeah, this is the first sort of touch operational user interface. You can see a small LED display there. And sort of through that, it's also generating the data of what crops work well, what's the ideal environmental conditions, and that's creating our own intellectual property value of what we know works in the actual appliance. And skip forward, this is the batch manufacture, one of the first units that is then coming out of the production line. And this is all manufactured with local, or all manufactured as much as possible around the facilities and resources around Johannesburg. No injection molded components because of the extremely high tooling costs. A lot of the components, or most of the majority of the plastic components, are laser cut or vacuum formed plastic components. And the molds and patterns that are used to manufacture these components are all either CNC cut from nylons, or they're 3D printed and then cast with metal filled resin tooling. It's a very low cost tooling, but then allowing for small to medium scale batch production. And that coupled with hand routering of components, hand finishing, CNC drilling of holes, it allows for a high quality plastic and metal constructed product, and at the same time being able to suit the production resources that we have. So this is a assembly line showing the sequence of sort of assembly getting ready to get dispatched. And then the actual heart of the home farm unit is it's like the brain and the intellectual property, sort of the lifeblood of what we see as being the way that the technology can be taken forward. But to summarize about the appropriate technologies and the appropriate manufacturing side of things, this is just an overview of laser cutting, so additive manufacturing, so 3D printing, a lot of the custom small brackets and sort of internal assembly fixtures. To be able to 3D print those, it means that you can print one off, or you can do a batch of them. So that means the cost of the material versus the capital outlay, if it were to be injection molded, 3D printing becomes a very viable process of manufacture. Vacuum forming, vacuum form tooling, router trimming, all the face panels are all silk screened, and then vinyl cutting for some of the other components. So it creates a very, over the past few years, we've created this method of being able to take the product to market in one-offs or in small batches. And this is done in partnership or with the assistance of what we would call the Friends of Home Farm, which is the University of Johannesburg, Department of Industrial Design, Idea Mongery, and then also the Made in Workshop. So all within Johannesburg, and we're very proud that we are proudly local and supporting local industries and partnerships. Thank you very much.
Thank you, Martin. That was a very exciting example of appropriate technology taken to the final stage in terms of actually implementation. We would have loved to have a video of that for our tech fair that's running concurrent with this, because we're very interested in actually the type of projects where you actually go to implementation. We have about 3 minutes to, if anyone else has questions, before we have to turn this room over for the next session to prepare. So can I get any questions from the panelists? You can unmute or let's see, I'm trying to see if we have any. Do we have anything, Gule, in the chat box or the QA?
Nothing on the chat box and nothing on the QA as well.
Okay. Okay. Are any of the panelists here? Do you want to ask the team any particular questions? So I'll ask a question. I like that you actually, like I say, in production here. And can you say something about your now that you're in production, where how you're marketing, how you're actually getting this out? I mean, it's a novel concept, so it's not a let's say natural market in the sense of people you can go right to. So how are you approaching that?
Yeah, so you're absolutely right. I mean, this is a completely new product category. So it wasn't a product that we could develop, and that there was a natural market waiting for this product. So, you know, the marketing has been one of our greatest challenges. There's a lot of education that needs to occur in terms of what a product like this can achieve and what the value is to the user. So in doing that, we found that getting the product in front of potential customers or just ordinary people was very important, because that was a way for us to actually demonstrate and how it worked, and really kind of give an expert perspective or view on the benefits and the value of such a product. So we really found that getting the product out there, selling direct to customer, means that we retain an element of control in terms of the messaging and brand. So, you know, as far as marketing, it's been direct to customer. It's been attending expos when we still could. This year has obviously been tricky in that regard, but we've attended expos in Pretoria and Johannesburg. We utilize social media quite a lot. We've got a loyal base of followers on Instagram and Facebook that we engage with on a weekly basis. We've really been very transparent from the beginning in terms of what we are. We are a small startup, and we enjoy engaging with our audience on our journey, and we really have a base of followers and customers that have been eager to participate in our journey in a way that they wouldn't were this a mass-produced product sold through retail. So I think that the way that we've done it has made sense up until now, because we've got a small group of customers that we have a high touch engagement with, and we use them as part of our product development process to get feedback and to improve the product with every batch that we run. But soon we're going to need to take the business to the next level, start partnering with distributors, retailers, and then we're going to need to shift our marketing approach. So yeah, that's. I hope that answers your question. I could talk for days.
Yes, I can see you. I can see you're very enthused about this, and your heart's in it. That's good. We're going to have to thank all our panelists at this time because officially 22 is when the next team is supposed to be able to set up there and test out everything. So this gives them a little more than 15 minutes to go into session that starts at 4 o'clock. I hope you all will be able to participate in the rest of our conference the next few days, and definitely Martin and Michael, I hope you're in contact, maintain contact with our network, because what you're doing is, like I said, very practical, and I think can be replicated in other areas. I'd like to thank all of our panelists. I think we had an exciting set of presentations. I particularly appreciate a number of those that linked into my own interests in terms of how to infuse appropriate technology in the city. So with that note, thank you everybody, and enjoy the rest of your day.
Thank you.
Thank you.
Thank you, everyone.
Thank you for the opportunity. Thank you. Bye.
You're welcome.
Thank you, everybody.